here's what we got. Like I said yesterday, I think sometimes like you can look at the visual pattern and say, okay, it's adding 3 each time, add 3, add 3. Like I can see that these 3, I get 3 more green tiles every time, right? Sometimes they can be easy, and sometimes they cannot be easy, right? What I showed you yesterday is a method that will work every single time, regardless if you have these nice 2 colors or not. Okay, good, Esme. So everybody can see Esme's screen, right? I'm just gonna draw a table. One sec, let me catch up. So you guys have your tables drawn already. And like any other table of values, right? We have like stage number here, and we have the number of tiles here, right? And like any table of values that you have ever seen, we put X and Y on top. Just for your own reference, right? You need to know that the column on the left is kind of the X, and then on the right we call that the Y. Additionally, some fancy math terms that we use, we call this the independent variable, and we call this the dependent. Okay, we're going to see this in a couple minutes too. Okay, where the number of tiles that you see or count completely depends on which stage number you're in. That's where that comes from. Okay, now I'm going to continue going through here. I always leave myself a stage 0 because I know I need it, right? And then you can go through and draw stage 1, 2, 3. Oh, I didn't leave you guys enough things. We don't necessarily need stage 4, but you guys can you can tack it on at the end if you'd like. Okay, and then I'm just going to draw. See, I drew those tables with the shift thing. I made those last night after I learned about the shift key, the trick. Okay, and then you just start counting tiles, and you say, okay, you're just counting. This is a counting exercise. We're going to say, okay, well, in stage 1, I see 5 tiles. In stage 2, I'm going to see that there are 7 tiles. And in stage 3, I'm going to see that there are, well, am I counting? Well, I can't even count. Look at me go. 8 tiles. And in stage 3, I'm going to see 11 tiles. And in stage 4, I'm going to see 14. Okay, and yesterday we talked about this additional column that you guys can add called the first differences. And the first differences tell us what kind of graph we're going to get, right, for your purposes. So I see that the first difference is here, and we're talking about how do I get from stage 3 to stage 4, and how do I get from 2 to 3 and 1 to 2. It looks like I'm adding 3 each time, right? Because these all match, the first differences are the same, I know that this pattern is linear. Okay, did we just get an emergency alert? My phone just went off. So because I know the first differences are all the same, that's a linear graph. That is a graph that we just graphed up here, a line. Okay, it's increasing by the same amount each stage increase. Okay, and then, so you guys know, if you look at this big, this is why I wrote this equation, where it came from. First differences were a part of this M value. The M, first differences. Whatever that number is, right? So if I were to go back down to my visual pattern there, I'd say, okay, the number of tiles, or Y equals the first differences, 3, times the stage number, X. But the problem is, I don't know what my starting value is. That goes right here. Right? I don't know what it is yet. But you can find it out by using this pattern that you see here, right? Well, I know that this is not going to change, right? So instead of adding 3, because I went from 1 to 2 to 2 to 3 to 3 to 4, that's increasing. But instead of going up, I'm just going to go backwards. How do I get from 1 to 0? Well, I just subtract 3 instead. So I go 5 minus 3 gives me 2. This is my starting value, or my B value for my equation, right? I think coincidentally, did we just graph that too? No, we graphed something close to it. We graphed what this would look like. All right. You could use the graph to tell you how many tiles you could expect to see in stage 100 if you use the graph. Okay, I'm just going to bounce through the Jamboards here and see what everybody's done. And then if you are done, this is your rule or your equation, right? What I will do on the formative, sorry, let me just do one more step. I want you guys to use the equation on the formative to answer how many tiles will be in stage, I don't know, 16. Okay, stage number. I see the word stage in my question. Right? I see how many in stage 16. I see that word stage. Where does the stage number go? Stage number we said was X. Right? Well, where's X in my equation? Right here. Right? So if you want to figure out how many tiles are going to be in stage 16, right, you could say Y equals 3. Where's X? Right here. We'll put the 16 in there. Right? Plus 2. I don't know what 16 times 3 is. 32. Another 6 would be 38. 10, 48. So we get 48 plus another 2. That should be 50. Then you could say, therefore, you guys don't have to write all this. It's a lot, okay? This would be what I would expect on a quiz. Okay? I would do this math piece and tell me that it's 50, but on a quiz or a test, I'd say, therefore, stage 16 will, that was a horrible W, 50 tiles. And you'd be done. Okay? Okay, so I'm going to flip through the Jamboards now. I'm going to put this one up. And what I want you guys to do is have a go at this. Okay? Figure 1, 2, 3, input, output, number or stage number, and how many tiles. And then why don't you tell me, to finish off the question, what the stage 13 has. How many tiles? In stage 13. Okay, and I'll bounce through the boards and just I'll use red, you guys use whatever other colors, and then you guys can see what I've written, okay, as I bounce through the boards. Okay.